Okay, now we're going to review our metric system because our metric system is what we use to conduct our science experiments. So our essential question for today is, how do we use the metric system? So this goes with learning target 4, identifying when you would use the base units of measurements and be able to convert from large to small and small to large measurements. Okay, so remember from last year we did a metric Olympics lab. You guys had lots of fun with that. And the metric system is different than the normal English system that we use, like inches and pounds. That's the English system. Now, everybody else in the world uses the metric system to measure things. And since everybody else in the world uses the metric system, when we conduct science experiments, we put our science data in the metric units because we might want to share our results with people from other countries. And we don't want to have to worry about converting the English system to the metric system. So that's why science has always done the metric system. Really wish America would just go to the metric system. Maybe one of these days we will. So let's start off with the base units. The base units are your standard ways of measuring any type of measurement, and they're just the standard. There's 3 types: meters, liters, and grams. So remember, meters is used to measure distance. Okay, so we use the instrument of a ruler sometimes to measure the distance. Liters is used to measure volume, how much space matter takes up, and we usually use a graduated cylinder as the instrument. And then we have grams, which is used to measure mass, and we use a balance. And in parentheses, I've also given you the abbreviation for each unit. So meters is M, liters is L, grams is G. Okay, so when we look at the metric system, there is a scale that we use. Oops. And that scale looks kind of like a staircase, or yeah, it looks like a staircase. Kilo is the largest unit. Milli is the smallest. If you notice in the middle, here is our base units: meters, liters, and grams. Now, the nice thing about the metric system is it's based on powers of 10. So milli is 1,000 times smaller than the base units. Centi is 100 times smaller than the base units. Deci is 10 times smaller than the base units. This is why we call these the base units. They're the standard. And these are powered by how these are 10 times bigger, 100 times bigger, 1,000 times bigger than our base units. Now, the 0.1, 0.01, and 0.001 are going to be used when we do conversions. But that kind of gives you an idea of a scale that we use. So when we're measuring the distance from like Denver to Dallas, Texas, which is where I'm from, we're not going to measure that in meters. Because you've seen my meter sticks in my room. That would take way too long. So we have to use a larger unit. So we use what's called kilometers, km, to measure large distances. Okay, if any of you decide to run the Boulder, it's put in kilometers. It's called a 5K. No, I'm sorry, 10K. It's a 10K race, which is about 6 miles, 6.2 miles. Hecto is slightly smaller than kilo, okay, and then deca, and then, like I said, then we go to deci, centi, milli. Now, if you notice underneath, depending on what we're measuring, for measuring distance, then we'll use the kilometers, the hectometers, the decameters, the meters, decimeters, centimeters, and millimeters. And which unit we'll use will depend on the size of the distance. So like I said, if we're doing long distances from Denver to Dallas, we're going to use kilometers. If we're using small distances, like the distance from eyelash to eyelash, we might use milli. If we're looking at the length of our finger, we might use centimeters. Okay, so this gives you an idea of what we'd use them for. Then when we go to liquids, if we're measuring liquids and we want to find out how much liquid is in a milk jug, then that's going to be just the liters. If we want to measure how much liquid is in Dillon Lake, we'll probably use kiloliters. If we want to know how much liquid is in a teardrop, we'll probably use centiliters. If we want to know how much liquid is in Oh, what's smaller than a teardrop? It's a liquid. I'll have to think about that and come back to you. Okay, so that's just the idea of when we would use liquid volume. If we're measuring mass, let's say we're measuring the mass of a pencil, we will probably use just grams. Whoops, that just totally covered it up. Didn't realize that. Okay, if we're using the mass of a paper clip, we might go into milligrams because the paper clips don't have much mass. If we're measuring the mass of a lion, we're probably going to use kilograms, or an elephant. Let's do an elephant because that's really massive. Okay, so that's our scale for our metric units. There it is. So make sure you get that down because you're going to have to know that. Oh, I forgot to tell you guys, there's an easy way to remember the order. Start with the first letter for each unit. King, Henry, drank, DK. Moldy, we just take one base unit, the M. Disgusting, curdled, milk. So again, I'll say it again. King, Henry, drank, moldy, disgusting, curdled, milk. You remember that saying? That helps you figure out the staircase for your metric unit. Okay, the last thing we're going to talk about is how you convert. So sometimes we make measurements in millimeters and we want to convert them to centimeters. So they're a little bit easier to, it's not such a big, maybe it's a really big number for millimeters. We want to convert it into centimeters, make it a bit smaller number. So there's two basic rules when you convert. When you're converting from large to small units, so we're going from like large units like kilo down to milli, large to small. You travel down the staircase, so you move the decimal how many spaces to the right. The number of stairs you travel is the number of spaces that you move the decimal. We're going to do some examples to show you this. The next rule is the opposite when you convert from small to large. So now you're going from milli to kilo. You travel up the staircase, so you're going to move your decimal however many spaces to the left. The number of stairs you travel is the number of spaces that you move the decimal. Okay, so let's do some examples. So if you have 10 centigrams and you want to convert those to kilograms, I'm going from centigrams to kilograms. So I'm going from small to large. So if I'm going from small to large, then I'm going to want to move my decimal to the left because we're going up the staircase. So I'm going to move my decimal to the left, kind of in a left direction if you look at it that way. Then I'm going to need to count how many stairs that I go up so I know how many places to move my decimal. So if I start out on centa, okay, and I'm going to kilo, I'm going up 1, 2, 3, 4, 5. So I'm going to move my decimal 5 places to the left. Okay, so let's take a look on how that works. Okay, so I'm in this first example, I'm going to move my decimal 5 places to the left. So I'm going to start, if it's just 10, the decimal is always at the end of the number. So I'm going to move my decimal 5 places to the left. Okay, so here we go. 1, 2, 3, 4, 5. And that's my decimal. So if you notice, I've got some blank spots, so I have to add some zeros. 1, 2, 3. Okay, once I've done that, I now get my answer as 0.001. So 10 centigrams is 0.001 kilograms. There we go. Okay, so let's do the next example. So the next example, I have 0.0056 hectoliters, and I'm going to convert that to deciliters, not decaliters, because deca has the K, but deciliters. So I'm going from large to small. So I'm going to move down the ladder. when I go from large to small, I'm moving down the ladder. So I'm going to move my decimal to the right, however many stairs I go down. So let's look how many stairs we go down. We're at hectoliter. We're going to go 1, 2, 3 to deciliter. So I'm going to move my decimal 3 places to the right. Okay, so again, on this one, since I'm going from large to small, I'm going to move my decimal to the right, and I go down 3 staircases, so I'm going to move 3 places to the right. So here's my decimal. I'm going to move it 3 places to the right. 1, 2, 2, 3. And there's my decimal. Okay, so after I've moved my decimal 3 places to the right, I am now left with the answer 5.6 deciliters. Okay, let's do the last example. The last example, I'm going from millimeters to meters. So I'm going from small to large. So I'm going to move my decimal to the left because I'm going up the ladder. I'm going to count how many stairs. 1, 2, 3. So I'm going to move my decimal 3 places to the right. Okay, so again, remember if a number doesn't have a decimal, then it's always at the end. So here's my little decimal right there. So I'm going to move my decimal 3 places to the right. 1, 2, okay, let's try that again. 1, 2, 3. And there's my decimal. So I'm going to add my 3 zeros. So it's going to be... Wait a minute. I wrote that down wrong. Oh. Okay, I apologize. I don't know what I was thinking. It's moved the decimal 3 places to the left. So if we were in class right now, you guys, I know, would have been stopping me. So remember, we're going up the ladder from small to large, so we're moving to our left. I apologize. So I'm going to take it and move it 1, 2, 3. And there's my decimal. Okay, and then you get the answer 12.345 meters. So that's how you convert in metrics, and you're going to get some practice with that. Okay, so hopefully after today, we have a understanding of what the base units that are used to measure in the metric system are, and we can practice with converting large to small and small to large metrics measurements.